Today we're talking about vector fields, and these are so much fun. Once we learn how to visualize a vector field, we can immediately see how useful they are in modeling lots of different phenomena around our world. So here's our definition of a vector field. A vector field associates a vector with each point in space. So in R2, we're going to take a point in the xy plane and associate each point with a vector based on a formula. And in R3, likewise, we'll have a point out in 3 space and we'll associate with each point some 3-dimensional vector. Most of the time, we're going to rely on technology to graph vector fields for us, and you'll see why in just a minute as we do this rather tedious and painstaking example. All right, so let's take a look at this very simple vector field, f of xy equals negative y comma x. So this vector field takes any point in R2, x comma y, swaps the x and y components. So x goes into the y component, y goes into the x component, and then we make that x component of the vector negative. So this will be pretty easy to come up with the vectors. Each point, like 1 comma 0, I'm going to swap the x and y components, and then I'm going to make the new x component negative. Negative 0 is just 0, so I'm going to leave that alone. Again, here I swap x and y components, looks the same, and then we make the first one negative. This next one, I swap x and y values and make the first one negative. Swap x and y values, make the first one negative. And we're going to go down and do this for the whole list. So there's our pile of vector outputs for this vector field. So when you're plotting a vector field, we're not going to plot all these vectors sitting with their tail at the origin. We're going to plot them at the point they're associated with. So my first vector output, 0, 1, I'm going to go over to this point, 1, 0. So 1, 0. And I'm going to graph the vector going from that point. So it's 0, 1. So 0 in the x direction, 1 in the y direction. So I'm going to go 1 tick mark up, and that's my vector output associated with the point 1, 0. All right. When I go to 1, 1, so I'm going to start off at the point 1, 1, and I'm going to graph negative 1 in the x direction, 1 in the y direction. So I'm going to go negative 1 in the x direction, 1 in the y direction, and I'm going to get that vector right there. All right. My third vector, so I've done the first two. My third one, I'm going to start off at the point 0, 1, so on the y-axis at a y coordinate of 1. And the vector that I'm going to plot is negative 1 in the x direction, none in the y direction. So start off at 0, 1, negative 1 in the x direction, none in the y direction. All right, so we're going to plot all of these vectors starting off at their point. So starting off at negative 1, 1 in the second quadrant, I'm going to go negative 1 in the x direction, negative 1 in the y direction. Next up, negative 1, 0. Negative 1, 0, and I'm going to go 0 in the x direction, negative 1 in the y direction. Starting off at negative 1, down in the third quadrant, I'm going to go 1 in the x direction, negative 1 in the y direction. Last one in the first column, 0, negative 1. So I'm going to go over to 0, negative 1, go 1 in the x direction, 0 in the y direction. All right, so I finished up that first column. We've got 4 more vectors to plot. So the first one in the second column says start off at the point 2, 0 and plot the vectors 0, 2. So I'm going to start over here at 2, 0, and I'm going to go 2 in the y direction, none in the x direction. So this is a much longer vector. Then I've got 0, 2. So I'm going to start off on the y-axis at 2. I'm going to go negative 2 in the x direction, 0 in the y direction. Negative 2, 0. I'm going to start off on the negative x-axis, and I'm going to go 0 in the x direction, negative 2 in the y direction. And then my last vector to plot is down at 0, negative 2 on the y-axis. We'll start there, and we'll go 2 in the x direction, 0 in the y direction. All right, so after all that work, we plotted a lot of vectors, but we may not really have a good idea of what this vector field looks like. If you go to the resources for the week, I have several vector field plotters linked there. We've got 2 for R2. You can pick your favorite. They do the same thing. And then one that'll plot vector fields in R3. So I'm going to go plot the one we were just doing by hand in the first R2 vector field plotter. And it gives me this. So Something that a computer will frequently do for a vector field is to shrink the arrows down. You can see that you can't really see what's going on with this vector field if we plot everything at its actual length. So down at the bottom where it says v=1, I'm going to slide that down and I'm going to give it a multiplier that says, hey, just shrink these vectors down for me so I can kind of see what's going on. And so it's still plotting longer vectors where longer vectors belong and shorter ones where shorter ones belong, but they're all at like a tenth of a length of what they're supposed to be. And you can definitely see the rotational nature of this vector field now. This kind of looks like what a fluid would do as it was going down the drain. This vector field, you might imagine, might represent the poles of a magnet, one of them sort of repelling and the other one attracting. This vector field has sine of x and y combined in different ways for the two components, and it gives this kind of neat fluid flow look to it. So we've already seen a couple of vector fields that we could imagine being some sort of model of a real life phenomenon. And this is really what vector fields are good for. So we've got a vector field graphed here on the top that's modeling the gravitational pull of the Earth and the moon. So you could imagine that this would tell us what would happen to an object that's maybe sitting here or maybe over here, and maybe make us question what would happen to an object that's somewhere in between. Where would it get pulled towards, the Earth or the moon? And then we have another fluid flow picture down here, which also illustrates something that's very common with vector fields. I mentioned that sometimes we have to shrink the arrows down to show what's going on so that the vectors don't just look like a pile of sticks laying all on top of each other. Frequently, we will also add colors to the graph that will show that the longer vectors or the vectors with greater magnitude will be perhaps like in this picture in red or yellow. And then the ones with a shorter magnitude, smaller velocity of water in this case might be towards the green or the blue. So we can represent that with the length of vectors, or we could also come up with a color scheme. Meteorologists use vector fields to model wind flow. We've got a wind flow vector field up on the upper right, and then we have an actual wind flow vector field from Hurricane Katrina down on the bottom right. The last thing I want to do is show you a few vector fields in R3. We definitely are not going to plot these by hand. We want the computer to help us out here. So here's one where it looks like all of these vectors are sort of exploding out from the origin, and you can rotate this around and look at this vector field from different angles. This applet also has a scale where I can make the vectors a bit longer, or I can make them shorter to make it easier to look at the picture. This one looks like it has a little bit of swirl going to it. And this one I love. It just kind of depends on what angle you look at it. You see all these interesting different patterns that are going on. And you could imagine this being like a wind flow and imagining what the particles would do if they were trapped inside this wind vector field. Again, if you decide to play around with these vector fields, you might get a big mess like this. This vector field plotter has that scale plus or minus. I can hit the minus and it's going to shrink down these vectors so I can kind of see what's going on with the flow or the pattern of these vectors out in R3. So I would encourage you to play around with these vector field plotters and see what kind of interesting vector fields you can come up with.